Hello and welcome. It's great to have you back. Today we are going to look at pandas and continue to learn about new methods that we can use in pandas. So specifically we are going to look at how we can add replace elements from series. We are going to look at how to add columns to a data frame. We'll also look at how to use the .at and .iad functions to access data. Finally, we'll also look at how to use booleans to access and filter data from series and data frames. So I've already created the Jupyter notebook, as you can see, and I've gone ahead and imported two libraries that we'll need, which is import numpy as np and import pandas as pd. The data that I've created, one is a series, which you can see here, pd.series, and these are just numbers from 1 to 10. And then the second data object that we have is a data frame, pd.dataframe, and it has three columns, a, b, c, where one column a is numbers, integers, floats, and then the last column c is strings. So let's get started. The first what we are going to do is work with series, and we'll try to access elements of a series using pandas. So here a is equal to a is our series, which looks like this. Now when we say a dot 0, we get the value for 1, which is at index 0. Let's say now we want to put an element in this particular series that does not exist. So let's say we want to add a number at index 12 which does not exist currently in the series, and we want to add a number 1000, let's say. Now when after adding here, we can see that the number 1000 is added at index 12 in that particular series. Now if we were to look at index 9, we definitely would find the answer 9 has a value of has the element 10 in there. Now if we were to look for index 11, we get an error, and that's because there is no index 11 currently listed here. So what about 12? If we look for 12, we do get the 1000. So that's one way we can add an element to the existing series. Now if you are looking to change the indices so that these are in a sequence, so after 9 you want this to be 10, that can be done, and to do that we have to reset the indices. To do that, we want to type a is equal to a dot reset underscore index, and then drop is equal to true. So this drops the column of index that's created. So here we have now a new series which has the new element 1000, and it is after 9, so it has an index value of 10. Apart from this, there is another append method that we can use to add elements to an existing series. Now if to do that, if you type a dot append, and here if you specify the element which you want to add, such as 999, and if you run this is going to give an error, and the reason is because cannot concatenate. So here the reason is because the append in pandas is here, it's expecting a series to be appended with a series. So to make this work, we want to change this to a series by adding pd.series in front of it. Now when we run this, we get a series as shown here. So another thing here, again we see that the index for 999 is 0. So if we want that to be 11, we can do that, and to do that, let's put this equal to a, and a is equal to a dot reset underscore index, drop is equal to true, and a. So now as you can see, we have a new element added to the series which has index value of 11. Next, let's look at how we can add and move columns in a particular data frame. And the data frame that we have created above is this one. let's say we want to create a new column E which has the same elements that are in column A. How do we do that? And there are different ways we can do it. So one is if we create a column E and we can simply assign it the values in column A. Now if you look at df, we have a new column E which has all the same elements that are in column A, 1 through 10, and E also has 1 through 10. There's another way using the lock command where we want to specify df.lock, and here we can go ahead and create another column F, and to give it the values from the column, let's say this time we use the column B. So if you look at df, now we created a column F which has all the values in column B that we see here. So there are different ways in which we can add new columns to a data frame. If we want to add a data to this data frame which is outside this data frame, that is also doable. So let's say we want to create a column name outside data. So here we can say it has to be a Pandas series. So say pd.series, and here we can say np.arange and say 10. Now if you look at df, we get a new column that was created which has the values going from 0 to 10. Now let's look at how to use iAdd and add. We have previously looked at iAdd. I just want to go it again with another example. Okay. So we'll use the time it to check how much runtime the iAdd has versus the ilog. So in this particular series that we have, let's use the data frame. So in this data frame, if we pick a value from say position 0, 0, and for this we want to use ilog because we are using indices. So 0 for this, 0 is for the row index 0, this is for the column index 0, and when we run this we'll get the runtime, and this is time it df.iAdd, and this again let's use the same indices, and this should be relatively faster as compared to this ilog that we have above. And as you can see, this is 8.9 microseconds and this is around 13, so it's pretty fast. Another item that we can use is the lock. Sorry, we already used the lock. We used ilog, so let's use lock now. The df.lock, and use the same index. Sorry, this has to be a, because we are using label for column in case of lock. And let's go ahead and time the second one as well. Time it df.lock, sorry, df.add 0, and again we are going to use label here. So as you can see, different methods have different time it takes to access the data, and the fastest we can see here is using df.add to access the same data from that particular data frame. Moving on to the next topic, let's look at Boolean indexing, how we can use Booleans to access data from either a series or a data frame. Now the series that we have is this, and from this one, if we want to pull all the elements from this series which are say less than 5, how do we do that? A is A and then A less than 5. So this pulls all the elements that are less than 5, and the way this works is, first what we are doing is checking the condition A less than 5. When we check that condition for that data frame, sorry, that series, we get a series back which is a Boolean series, and in that particular series the true and false are flagged for each of the element, and that tells Python which items should be passed to the output and which items should not be passed to the output. So here whichever is true, it moves on to the output, whichever is false stays there, it is not in the output. And therefore here when we put this particular Boolean series in here, we get only those true values from that particular series. Similarly, if we can check more than one condition, so this essentially we can call this as a mask. So if you say this is a mask, let's say mask is equal to this, and now if you look at mask, we have the series in it. Now if you go back and say use this mask to filter the data from existing series, and there you go, get the filtered series using that particular Boolean series mask. Now if we have more than one condition, how do we do that? So if we have let's say if we want to check a greater than 1 and we want to check a less than say 7, okay, now to check these two conditions, first we can create the mask that we created here, or we can use it directly. So to use it directly, we can specify it in a square bracket and within parentheses a greater than 1 and a less than 7. Now this is going to create a problem because we are using the letter AND, which is the logical AND. Here in case of Pandas, we have to use the bitwise AND to do element wise comparison. So here we want to use the ampersand and not this particular AND. And when we run this, we get only those elements that are between 1 and 7, which are 2, 3, 4, 5, 6. The way this works is when we run this particular condition here, we get a Pandas series back, which is a Boolean series with true and false values for all the elements which are greater than 1. Okay, so if it's less than or equal to 1, we get a false. It should have here, right? So if we look at A, so 1 and 2, so 1 is false, which is correct, and then from 2 onwards it's all true. Similarly, when we run the second condition, A greater than less than 7, we get this particular series. Now what the ampersand AND operator does is it compares this false with this true, and then it creates additional Boolean series which also has true false in it. So false and true becomes false. So false, you can think of false as 0 and true as 1. So 0, 1 is 0, and then true, which is 1, 1 is 1. And finally, if it's true, false, it means it's 1 and 0, that is false. Okay, so if we let's say if we put this in another variable w and run this, and if we put this another variable v and if we run this, and now if you were to check what the Boolean series looks like with ampersand, we can do that. So this is what we get, and as you can see here, we have false for the first one, true for the second, v, and the output should be false, and it is false. Next, for index 1 we have true for w, and for v we have true, so we have two trues, so output should be true, and we have true in the final output of the ampersand AND. Now when we put this particular condition right here in this case, then we get the output that we saw earlier. So if you say A and V and W, then we get the filtered output back from that particular series. Next, let's look at a way in which we want to select items that are opposite to the condition that we are applying. What I mean by that is, let's say we have a condition that is items that are greater than 5. We get, so this is the series that it generates. Now what if we want to select all the items that are not greater than 5 or opposite of this condition? To do that, what we can do is we need to add a tilde in front of this one. Okay, so when we add the tilde, it we get the opposite response. So if I go ahead and copy this, paste it here, and let's leave it as is. Now if we run this, as you can see, these first 4 were false. Now all those first 5 were false, and now all those 2 are true. So it flips the true and false. Now if you put this in the series as a filter, as a mask, then you get the opposite result. So all the numbers 5 and below are in the output. So that's the operator that can be used in those particular cases where you want to select the opposite of what's in the particular condition. Next, let's look at how we can select data from data frames. So for data frames, here we have our original series, which is this, to which we have gone ahead and added a couple of columns. So let's say we want to pick rows from this particular rows and columns from this data frame based on a condition for a particular column. What I mean by that is, let's say if we want to pick only those rows from this data frame that has a value of in column A less than 5. So we want all these columns and rows up to here. We don't want anything below it. So to do that, we can specify df and A. That's the column we are going to use, and we want all the columns less than 5. So we say less than 5, and this gives us only those columns back, as you can see here. And similar way, if we look at this mask or the filter that we create, this again would be a Boolean series for column A that tells Python to include or exclude those rows from that data frame in the output. Okay, and similar to Pandas series, here we can go ahead and use multiple conditions to extract data from the data frame. Let's say we want to pick we have condition where we have this column A, or we can pick another column. Now let's pick column B. Column B where the values have to be either greater than or equal to 0.6. Okay, and we need another condition. We can add another condition where the value in column E has to be less than 9. So value in column E has to be less than 9. So if these are the two conditions, how do we go about coding it? So we have to do it in the same way as we did above. So df open close square brackets, and here we want to specify df and for B, and then open the greater than sign equal to 0.6, and before we use the ampersand, we want to put this in parentheses, and then put ampersand open close parenthesis. Here we write the second condition, which is E less than 9, and this should work. The reason why we put ampersand here and we need to have the parenthesis is because of the priority. So this ampersand has a higher precedence, so it gets operated first, so we won't get the condition same if we use the ampersand without the parenthesis. So these parts will get executed first. So let's run this, and here we get 5, 6, 7 indices for the output of the data frame. So I hope you have learned something new today, and next lecture we'll look at how to use is in, not, and in commands. We also have a where command that we are going to look at in coming videos. So keep learning, and I will see you all in the next video. Please like, share, and subscribe. It helps me stay motivated to upload more videos for you guys. Okay, thank you.